So our library NumPy, one of our most useful libraries, uses something called an ndarray, which has many functions for analyzing data. And there's a lot of other libraries in Python that require NumPy as a prerequisite because it actually uses that data type ndarray for the functions in their library. And this array can easily store two-day matrices or tables, or even very large matrices. So when we're using this library or any library in Python, the first thing you're going to do is import it. So at the top of every function, you'll have this import command. Right here, you'll see we're importing the NumPy library, and it commonly uses the alias np. Most of the libraries in Python have a common alias that's used. So after it's loaded, np can be used to access any of the NumPy library functions, which is great. And we have to use, again, that shorthand np. So like right here, this array is in NumPy, so we use np.array. So we create a new list. This list only has 4 integers. And then we pass the list to an array to change the data type from a list to an array. We could print the array and then check the type of object it is. So you'll see when we printed it, this is our array that we designated here, which is not a list anymore, it's an array. And then when we check the data type, we could see that it's a NumPy ndarray. So let's say we want to check the number of dimensions, size, and data type because we have this huge data set again of 10,000 integers. Except for this example, we only have the 4. So when we print our ndarray, again, here's our output. And then we pass our list again to the np.array function. And we're combining this array into a larger matrix. We're using list 1 from the previous slide and then this new list 2. So you could see our new output. So if we want to check some of the characteristics of our ndarray, there's an easy way to do this in NumPy called the shape attribute. And so we could get this data using this array.shape, or the name of our array.shape. And you don't have to designate a name for this, but I like to do this because I've been using Spider recently. And anytime you create a new variable designation, you could pull it up in the Spider and look at it, which I feel like it's very helpful. So here's the characteristics of our ndarray. You'll see that we have integers in that array. And you see our sizes and values here in the window. If we want to check the number of total items in our array with the size attribute, we could just use this command array2.size. You'll see the length is 8. If we want to check the type of data in our array, you could see that this is a type of integer in Python, integer 32. So there are many ways to create an array in NumPy. One common thing that's done in programming is initializing an array or matrix with zeros or ones or sometimes NaNs, depending on what you're doing. And usually that just initializes, let's say, a 5 by 5 matrix. And then we can use that 5 by 5 matrix of zeros or ones to do a number of other operations with. But it just provides a starting way of initializing basically a type of variable. So Here in this slide, we initialize an array filled with ones, and we use the numpy ones command, and we want an array that has 4 columns and 3 rows. So that's what we initialize here. You could see this is the array we initialized on this slide. And just like the previous slide, this is a way to initialize an array of zeros. So this time we want an array with 6 columns and 4 rows. So here is our new array of zeros that we could use for whatever other operations that we need it for afterward. And also another common operation that's conducted in linear algebra is initializing a matrix with ones across the diagonal for whatever operations or functions that it's needed for. So in the NumPy library, we use the identity command to create a square 2D array. So here we initialize an array with 4 columns and 4 rows, so we have n equals 4, and this would be the output in the console.